Okay, well, hey everyone. Welcome to the July 2021 PyData Triangle Meetup. Today we'll have two different speakers talking about the same subject, which I'll get into after some announcements. Yeah, as always, Velasys Digital sponsors this conference. Velasys Digital is an advertising and marketing company that predicts consumer behavior and builds compelling media moments for brands. Usually we have this at the Velasys offices, but during the pandemic, we are on Zoom.
And our name has changed to Veracast. So we're in the process of working through that marketing transition.
Veracast. Yeah, another one of PyData's sponsors is NumFOCUS, and NumFOCUS is a nonprofit that promotes open practices in research, data, and computing. Yes, as always, here's our code of conduct. I'm sure most of you have read this by now, but just a quick refresher. PyData is dedicated to providing a harassment-free conference experience for everyone, so please be kind and professional. So don't be mean, be average, or be above average. Almost messed that up.
Good to say that because we have the troublemakers here.
Yeah. Another announcement, we've gone bi-monthly and have been for a while now. So our next meetup will be September 1st, 2021 at 6 p.m. on Zoom. A question we've been asking recently is how can we serve content that you want or need? So if any of you have like data science topics that interest you, if you want to give a talk or you know someone who'd like to give a talk, if there are any activities that you want to organize, please reach out to Mark, Drew, Jean, or I, either on PyData or on Meetup or on email. Or you can ping me here. Yeah, so before we get into the talk, does anyone have any event announcements or job opportunities they'd like to share?
Arti?
Yes.
If anyone is interested in the Alteryx designer user group, we are meeting in August 18. We don't have the announcement up yet, but I'll just post a link to the LinkedIn group.
Good.
Thank you.
Yeah.
And Veracast is has a few positions open for marketing scientists and data scientists and engineers. I think there's probably 2 or 3 openings in each one of those areas. No need to have ad tech experience, but I think all 3 of those positions are looking for 5 years or more experience. And just one other note, we are really shooting to do this as a physical meetup in November. It won't be September, but we're really hoping that we can get the November back into sort of a dinner and presentation night at our offices in Morrisville.
I really miss the free food.
And Arthi, actually, there is an opening that I would like to say. I'm working at Central Square, which is a public administration and public safety company. We have a few software developer positions open, product manager positions open, QA engineer positions open, and we have a number of product owner positions open, as well as the product support positions.
Cool. Yeah, as always, please post any links in the chat if you have them. Yeah, anyone else? Cool. Another thing to keep in mind, so we'll have our lightning talks at the very end after our 2 speakers present. So if you have an idea for a lightning talk, please ping me in the chat and I can kind of schedule that in for the end. Awesome. Okay, so I'll kind of introduce both of our speakers at once because we'll be presenting on the same topic, which is how to distill Amazon reviews into a representative subset. So our first speaker is Leo Gokce. And he recently completed his Master's of Science degree in Computer Science and Information Systems at UNCW, focusing mainly on database management. Leo is currently a full stack software developer at Central Squares Technology. So he'll be kind of giving like a project overview and about selecting optimal subsets of Amazon reviews. Our next speaker is Ryan Woodall. Ryan has a Master's of Science degree in Computer Science and Information Systems. As his capstone project, he designed and implemented a fully automated data pipeline for collecting and preparing Amazon reviews. And since receiving his degree this year, he works as a mentor for aspiring high school students through Polygents and is currently exploring job opportunities in data engineering and related fields. So he'll be speaking about the data engineering side, so large-scale data pipeline for scraping the Amazon reviews. And before we get into it, Mark shared an interesting quote that's kind of related to what we'll be talking about today that might spur your interest. So it reads, if similarity search is at the heart of the success of a $1.6 trillion company, Google, there's a good chance it's worth learning more about. So with that, I'll stop sharing, and then Leo, if you want to kick us off.
Sounds good, Arthi.
Okay, how do I stop sharing? There we go.
All right. And I should go to slideshow from the beginning. Okay, so my thesis topic was on automated text reduction and comparison of reduced reading list creation models. This was inspired by Klein's 1998 paper, which was a working paper that he did not complete and experiment with, but he had some ideas that I thought were worthwhile to look at. In my presentation, I will state the problem, talk about the metrics, optimization models, data, the numerical representation of text data, results, and then discussion, and then limitations and future research. But before that, let's talk about what's the problem you're trying to solve and look at. Now, with the exponential growth in the technology, there are more and more information being entered into internet and other data sources. Now, with this exponential growth, it is becoming really hard to read documents and get the information when you have high redundancy within documents and across documents. So we said, can we just select some of them and by reading them, get most of the overall corpus? So if we had 100 reviews or 100 documents, is there a way to pick 3 that would represent the overall the best? And the second important part of our project was making it in a way that it is easily repeatable. So this methods we use should be able to apply to any data set in similar format without requiring any changes. So things like stop words or term elimination or dimension reduction, we try to make it in a really standard way so that it is repeatable. Now, actually, before going into too much detail, let me tell you what Dr. Klein did in the previous presentation. At that stage, I had the data collected from Amazon using the web scraper tool. And based on that data, we looked at some statistics on the data, such as the review counts and the dictionary, which means the overall vocabulary of corpus. And we tried to visualize it using the word clouds and some histograms. At that stage, it was only about the overall corpus. We did not go into details of specific reviews. But after that, we actually applied the reviews for specific models described in Klein's 1998 paper. So for now, I think this is sufficient information about the project. In my second part, I will actually talk about the implementation of this process.
Great. So Ryan, will you be talking about the data engineering portion?
Yes, I can get into that now. Let me share my screen. Wait, I'm in trouble here. Share this. There it is. Okay. So what I did was I created a data pipeline that's fully automated for scraping Amazon reviews and collecting them and preparing them for data scientists or whatever means. So first, a little bit, this is what I wanted to talk about, just a little bit about me, and then I'll go over to system overview, and I'll talk a little bit about the web scraper I used and some of the Azure components, as well as the data transformations that I had to do. And then a lot of the issues that I ran into with time and money. So I grew up in Smithfield, North Carolina, home of the Bright Leaf hot dogs and the Ham and Yam Festival, not too far from a lot of y'all. Received my bachelor's degree way back, I think it should have been around 99, but that was in music. And you can kind of see some of my pictures there of me on gigs. In 2005, I started working at Measurement Incorporated, which is based out of Durham, but I worked at the Wilmington site. Basically, they grade standardized tests, and as a scoring director, I oversaw the training and scoring of those. But in 2007, I returned to UNCW to get a master's degree in computer science and information systems, and that's where I met Dr. Klein, and became interested in data management science and engineering. And this brings me to my capstone project, which is related, as said, to the work of Leo, and it's part of a greater project Dr. Klein is working on. So now I'll get into the details of this project. So first of all, the system requirements. Basically, what I was looking for from a big picture standpoint is I wanted to be able to input a CSV file that was basically just a list of product URLs. And each product URL was the starting page for the reviews for that Amazon product. And then it would create scraping jobs for each product URL, retrieve the scraped data and clean the data and add it to a relational model. And finally output a JSON file of the entire collection of Amazon reviews. Some additional requirements were that it needed to be fully automated, exist entirely in the cloud, and utilize a third-party cloud-based web scraper that Dr. Klein and Leo were already using. I'll get deeper into the components of the system, but bear with me because there's a lot of moving parts and it's difficult to really figure out the best order to present everything without jumping around just a little bit. So this kind of shows the system overview. So you can see it does exist entirely in the cloud, and most of the work happens within Azure Cloud Services. But again, the web scraper part of it, that is a third-party service, which I didn't have to create, but I did have to configure components to integrate between it and Azure, basically by means of HTTP posts and things like that. And the Azure services, I was basically using a SQL database, a data lake, function app, and data factory. Before I get into Azure services, I want to talk a little bit about the web scraper. So webscraper.io is the free version, and it comes in the form of a browser extension. It offers user-friendly tools that allow you to basically point and click and to generate a sitemap, which is basically the instructions for the scraper in the form of a JSON file. There's a lot of tutorials and documentation, so it's pretty easy to create these sitemaps with only minimal knowledge of HTML. Unfortunately, I couldn't use the free version because I needed everything to be automated. But I will point out that the sitemap was originally created using the browser extension, and then it was passed along to me. The cloud version of this scraper, it offers API access, which would allow the ultimate automation that I needed, but it's not cheap. And I'll get to the cost a few slides down. What I needed the API to do was basically for creating the sitemaps and the scraping jobs, and then to be able to retrieve the data and delete the jobs. So to scrape reviews for a product, you actually need that sitemap first, and you have to create that for each product. So for each product URL, but the sitemap is pretty much exactly the same for each product with the exception of 2 fields. And I've highlighted those there. This is not the entire sitemap. This is just the beginning. It's several pages long, but you can see that I've highlighted the 2 fields that are different for each product. And it's basically just the name and then the start page, the URL for the starting page. And this is where the URL comes from. So this is basically just a reviews, the starting page for reviews for this P&E solid state drive. And this is the breakdown of the cost for the cloud scraper. As I mentioned, the browser's free, but then they have 4 different tiers. The project tier, $50 a month, professional tier, $100 a month, business tier, $200, and scale, $300. So at first glance, it seems like there's some pretty good options that are not that expensive, but there's some problems with it. The project tier doesn't allow API access, so that was out for me. The professional is $100 a month, and it allows API access and proxy manager, but you only get 20,000 page credits per month. The business is the everything offered with the professional, but you get 50,000 credits. And then the scale version, which is 300, has unlimited page credits, but there's no proxy manager. And I'll get into the proxy manager a little bit later on here. And again, these were the primary reasons that I needed to access the API. I've mentioned most of these, but there's this job completed notification. And I'm going to talk more about that when I talk about the Azure function. But basically what it is whenever a scraping job completed, the API would send out an HTTP post request to a pre-configured endpoint URL and letting me know that the job had completed. So getting into the Azure services, first I'll talk a little bit about the data lake. The most significant folders in the data lake I had a products folder, a job completed folder, raw data folder, and a final JSON folder. And the product folder just held the original CSV file with the list of product URLs that could be updated. And then the jobs completed folder, that's where I stored information about the jobs that had completed in the form of a blob. And so basically that would have like the scraping ID, job ID stored in it. So I would know that I needed to go download that data. And then there was a folder for the raw data once I downloaded it from the scraper. And the JSON folder is just where the final JSON output of the entire collection was kept. So with the Azure serverless function app, again, this was for the job completed notifications from the web scrapers API. For this endpoint that I needed to configure, I used this app, and the function app's URL effectively served as the endpoint URL. The function would be triggered whenever a post notification was received, and then it would parse the request body and extract the scraping job ID and the sitemap, and then write that to a blob, and and I could check that folder with the blobs later and download the data. There are some issues though when dealing with Python functions or writing Azure functions with Python. The reality is that Azure, being Microsoft product, naturally it's offering more support for C# and .NET platforms. And as a result, the documentation for using Python was sometimes slim compared to C#. And this also meant that I couldn't always do things the way I wanted. I had to make some changes here and there to my plan on the go. For example, I originally wanted to download the data right there within the same function. Turns out this wasn't possible. I was hoping that when the job completed notification came in, I could then right there send the GET request back and get that data. But there's some problems with bindings, which allow the function to communicate with other services. And the HTTP trigger function allowed an HTTP post binding set to in and an HTTP response binding to be set to out. And it allowed for other bindings, but it wouldn't allow me to add a second HTTP binding for that GET response that I wanted. It would require a second function, and unfortunately, you can't call a function from within an Azure function. So I had to create a workaround for this, and I decided I would just update the database so that I could later query it to find out if there were any jobs that had been completed and were ready for downloading. But again, another problem, for some reason, Azure does not support a Python binding for Azure SQL database. There's one for Cosmos DB, but not SQL Server, which I thought was weird. But I should mention that it is in fact possible to write directly to SQL database from a function written in C#. That is supported. My workaround for this was to use this blob binding. So I could create a new blob for each completed job, and it would contain the parsed information, sitemap ID, and all that. And then I could later pull that. Another frustration that I had with the Python functions was that writing and editing the code was not supported inside the Azure portal. Within Azure, all the services exist within that. In my case, they all exist within one resource group, and it has they all use the same platform. And since I wanted to use Python, it had to be a Linux consumption platform. And that meant that in order to write Python code for these functions, I had to do it within Visual Studio Code. And, you know, I kind of liked writing it in Visual Studio Code because there's some great extensions for Azure in VSC. But ultimately what it meant, due to the nature of the function I was writing, I couldn't test it from VSC. I had to deploy it to Azure, see if it worked, and then I'd have to go back, change something, deploy it to Azure again, see if it worked, rinse, lather, repeat. So this took up a lot of time because I was really new to Azure and writing these functions, and with the limited documentation, it was a lot of trial and error. So it took up more time than I expected with all the deployments that I wound up having to make. And this is the actual function. It's really quite simple, but this is the view in VSC. So it basically just takes in this request and parses it to get the to get the scraping job ID and the sitemap ID. There was one other issue that developed at this point when I was trying to do this, write this, and what I was supposed to be getting from the web scraper was a request body in JSON format. And it was actually not truly in a JSON format. It was more like a URL type notation. So it would be like scraping job ID equals 3465, and then the ampersand sign, sitemap ID equals 123. So it took me a while to figure out that that was what was causing my problems. So again, having to deploy it and then run it, it just took a lot of time. So it wasn't the easiest thing to do, or at least time-wise. And here's just the setup of the bindings. You can just see the 3 bindings I have here. There's the HTTP trigger for in and the blob, and the HTTP out. So the Azure Data Factory, this is where all of the pipelines exist and were coordinated. I had 4 main groups of pipelines. Each group can usually contain 2 pipelines. One of them performed all the primary functions, and the other one was basically just set to trigger by a scheduler. And all it did was check to see if there was any work that needed to be done. So it was the one that would be polling, say, the URL list to see if any new URLs had been added, or polling the completed jobs blobs to see if any new blobs were there. It would do that, and if there was some work, it would then execute the other pipeline, the primary pipeline. So there's 2 versions of Data Factory, the version 1 and version 2. Version 2 basically operates the same way as version 1, except there's an IDE, which makes building the pipelines incredibly fast and easy. The JSON is still working in the background, and it's just a click away though in version 2. You can toggle back and forth from the IDE to the code view. And looking at the code view was often helpful for me since, you know, I was learning this. I didn't always know what all the options were, and with the IDE, you have to click through all the windows and try to find every available option so that you can just figure out what's possible. But taking a quick look at the code, you could see all of the options. There was one drawback with working with this second version though, and that's that it's still being developed. It was not uncommon for me to have finally figured something out, and I go to bed, I'd wake up the next morning and find the options had been completely moved around, and in some cases seemingly gone. And I'd have to spend the next morning familiarizing myself with the new layout. So another time issue there. One of the things I really love about the Data Factory is the ability to create this dynamic content. So I could utilize variables and pipeline parameters by writing expressions to do this. So it was a bit of a learning curve for me on this, learning this expression language, but most of the functions at first, you could just click them in the IDE and it would create the expression for you. And this is primarily how I learned the language. And eventually I found it easier to just type the expressions rather than doing all this searching through drop-down menus to find a function. There was one strange quirk though when it came to variables in the Data Factory. While parameters could be of types string, int, array, bool, and object, variables would only support string, bool, and array types, no integer type. So a lot of times this meant I had to write expressions that would convert ints to strings when I was just to set the variable. And then when I wanted to use that variable, I'd have to convert the value of the variable back into an int when I was using it in some dynamic content somewhere. And the last point I want to mention about the Data Factory is regarding the file types. And this is just something I dealt with early on. I was in the learning process, so I wasn't sure whether it was better to work with CSV or JSON file types. So my final system wound up being a mix of both CSV and JSON data sets. Because at first I liked working with the CSVs, but really that was only because I hadn't really figured out how to the language for working with the JSON file types yet. The CSVs wound up causing me to have to do a lot more manual configuration, particularly regarding the column names and mapping schema, things like that. Some CSV files use the first row as a header and others didn't. So when it didn't use the header as the first row as a header, I'd have to go in and find out the index of particular columns to know what I needed to put into my expression. And this was never an issue with JSON, with this key value pair. So once I figured JSON out, that's all I wanted to use. And if I were to rebuild this, I would definitely work with JSON file types only if I can get away with it. It's just much easier. So the basic components in the data factory, the pipelines, you can create as many as you want. It's pretty cool because you can call other pipelines from within a pipeline. So when I was building the system, at one point, I think I had like 17 different pipelines. I was treating them like functions in Python, I guess. I did it this way because it made debugging much simpler. Being able to test the small components of the design individually. And once I had all the working components, I actually started combining them into larger pipelines. And ultimately, I think I wound up with 7 pipelines in the final design. The data sets are basically just the instructions for the file or data being used in the data factory activity. Usually you need 2 for most activities, 1 for the source data and 1 for the target or sync data. It basically just describes the details of the data, like where it's located and what link service is being used, and the format of the files, the schema, etc. The link service is what allows Data Factory to access other Azure services. This is where all the things like the permissions are set up. So for example, I needed a link service for Azure SQL Database, and I needed another one for Azure Data Lake. I needed a REST link service that actually linked to the web scrapers API to retrieve the data. And there's quite a few different activities to select from depending on what you want to do with or to the data. One of the most common activities is the copy activity, which basically allows you to move the data around. And here's kind of the anatomy of the Data Factory copy activity. It's basically, if you see here, this would be the file in the data lake, and this would be a table in SQL Server. And so you have this data set that basically gives me all the instructions of what this file is, and it includes the link service. So the copy activity can take that file and extract the information and then map it to the sync data set, which is the review stagings, and it's SQL formatted, and the links has the link service to the database. And basically, when this is triggered, it just copies everything from that file into this review staging table fairly quickly. And with this, I'll show you actually what that would look like in Data Factory. So here, basically, this is just this get metadata activity. It's just grabbing all the file names within the folder, and then this for each activity is creating an array of those file names. This is where the magic happens. It iterates over that array, and for each file name, it basically sets the file name to a variable, and then here's the copy activity. So this is what I was just describing. So you have the source, and there's the data set. It's JSON, and here's where it's located, and you can see the link service here that allows access. And then you have the sync data set, same deal. But then the mapping, this is where you can mess with it a little bit. So if I wanted to get rid of some columns, I could do that here. Or if I wanted to map things to different columns, I could switch all that. I can map it to columns that are not the same name. So a little bit of functionality there. And then basically after that, I won't get into the rest of this. This calls a stored procedure in the database that actually does all the work from that review staging table and does all the conversions and cleaning the data. So go back. So next, my original plan was not to use that review staging. So what I just showed you, that's actually what I wound up doing. But I want to tell you now what my original plan was. And that was to utilize a mapping data flow activity within the data factory for cleaning, converting the data before loading it into the database. It's really kind of neat. You can easily configure transformations using the built-in IDE. And if it doesn't have exactly what you need, then you can write a more complex expression. The expression language is not the same as the expressions used for dynamic content in the data factory. But if you're familiar with M-code, Power Query, it's not an issue at all. I did encounter some issues though when I started trying to use this mapping data flow activity. I was able to do the conversions and things like that, but what I wanted to do was insert the data into a product table, a reviewer table, and a review table, all from the mapping data flow. And it wound up taking a long time. It was a bit challenging and it was unusually slow, which costs money. And I want to talk about that now, but I wanted to pull this data model up just so you can reference. Don't worry about the two tables up in the upper left. They're just, they're not really a part of the final output. So really what we have is the product table, the reviewer table, and the review table. So what I had to do was first insert, into the product table so I could get that product ID. And then for each record in that file, I would have to insert into a reviewer, get the reviewer ID, and then insert the review into the review table. And once I got everything set up in the map and data flow and I'm ready to test, I decided I'll just use a sample of 1,000 reviews. And it runs and it runs and it runs. 400 reviews, and several hours later, I boarded the test. So the problem was that for each action, like inserting into the reviewer table, it was opening another runtime session costing 25 cents per hour per DIU. And the other issue was that these sessions were starting to pile up and some would be inactive for up to 4 minutes. Apparently Azure considers a 4 minutes to be the maximum cutoff for what's considered normal behavior. So I go and I check my account and I've spent way too much money for just 400 reviews. It was actually a little over $50 at that point. So that was just not reasonable. So I clearly it wasn't working and I had to rethink things. So to quote Jimmy Carter, if it ain't broke, don't fix it. So I decided to scrap the whole idea of using mapping data flows. And I went back to good old fashioned SQL to do the heavy lifting. What this meant was I would do all the parsing, converting, cleaning of the data with SQL expressions at the same time I'm inserting it into the database. And I just used that copy activity that I was just describing to copy all of the reviews for a single product into a staging table. And then I'd run the stored procedure that would take care of all the conversions and insert it. It was more work up front, but when I ran my first test, the time went from hours to just mere seconds. much more efficient. And I'd like to show you the stored procedure, but before I do that, I just want to give you an idea of what the data looks like when it comes in raw. This is actually a single record that's pulled from the raw data straight from the web scraper. I'm not going to go through all this, but I just highlighted a few things just to show you what I needed to do. Just a couple of things I needed to do. So the web scraper start URL, that's actually that URL that's from the CSV. I needed to parse that to get the name of the product and get the ASIN. That was one of the things I had to do. Another example is this reviewer ranking. It's not as useful this way. It's a string. So I wanted to remove that leading pound sign and get rid of the commas and turn this into an int. The idea here, though, was to not lose any data. So I didn't do away with the string. That's not the plan. So what I did was create another field, a second field that held the int. And I had to do the same thing with like review stars here and the helpful string. So this is just an idea of what some of the things I had to do a lot as far as conversions. Here's the stored procedure that I actually wrote. And I'm not going to go through it. I just wanted to kind of give you an idea here. This is what I had to do to parse the product information out. And then it would get the product ID and I'd insert into the reviewer. And here's an idea of some of the expressions I had to come up with. It's not too bad, but it did take a little bit more time than it would take using a mapping data flow. But it turns out to be way more efficient. And the last thing the store procedure does is it deletes everything from the review staging table after it's been inserted into the other tables. So that way it's basically ready to go on to the next iteration of the file names and repeat the process in that data pipeline. Let's get that out of here. So here's the data once it's in the database. So you can see I have a new field here, review stars, and it's just an integer 5, helpful count, integer 1. And you can see I still have that stars string in there and the review helpful string still there. So I'm not losing any data. That's what was really important with this, was the idea of not losing data, not changing the data in any way other than cleaning it up and providing additional fields with that clean data. And this is the data as the same record extracted from the final JSON output. This product is Hitchhiker's Guide to the Galaxy. I'll tell you a quick story there. One of the when I was downloading all the data and we're loading it into the database and I was deleting it during all the development, my product ID number kept getting higher and higher and higher. And when I got ready to run the final output or the final production run, it was actually pretty close to where the product ID for Hitchhiker's Guide to the Galaxy was going to be 42. And I was really hoping that it would be, but it wound up being 47 or 48. I'm a huge Hitchhiker's Guide to the Galaxy fan, if you didn't figure that out. Back to the web scraper, I want to dig just a little bit deeper into this. So first and foremost, with some of the problems, that it's kind of expensive. I needed that access. At the very minimum, I needed that $100 a month for development. 20,000 credits were enough for the development phase. But the idea was that I would upgrade to the scale version once I was ready for the production run. This would give me unlimited page credits, but it cost $300 for that month. And I would only need it for a month, but quite a jump in the price. What I didn't realize at that point in time was that the scale version did not include the proxy manager. I haven't talked about that yet, so I want to get into that. Basically, what the proxy manager does is it rotates through different IP addresses during the scraping, helps to avoid the bot detection, which is absolutely necessary if you're trying to scrape data from Amazon. They're on top of that. So the Scale subscription didn't have this option, but it did offer an option to add a custom proxy via a third-party provider of your choice. At this point, I was running out of time. I had just days to finish this project. So I didn't dig too deep into this. All I knew was that was an added cost, which was something I was not interested in at that point. So I wound up using the business subscription, which came with the proxy manager and 50,000 page credits, which was enough for me. I was only interested in scraping 15 products just to demonstrate that this system worked. But this is clearly not a big data solution where scalability is necessary. That's the main problem. So, going with the business subscription, it worked for me, but it's just not feasible. The last problem with the cloud scraper was that it didn't always perform as expected. I never had this problem using just the web browser, the free version, but sometimes the cloud scraper, it would finish scraping a product and fail to send that job completed notification. And other times it would stop a scraping job and never restart. With all this combined, it just made the cloud-based scraper not a feasible thing to use. The return just didn't justify the investment. By the time the project ended, I had spent $600 on the web scraper, and I had a little over 17,000 records from the 15 products. So alternatives, obviously, it got me thinking, what are some alternatives to this? And, at first I was thinking, well, I could utilize a virtual compute environment and run some kind of script that sort of hacks the free browser extension version. But this really isn't the best idea, in my opinion. I think it would be better to create the web scraper. And, there's Python libraries for this very purpose, like Scrapey, Selenium, and Beautiful Soup. I haven't really spent a lot of time researching what's out there, but I'm sure some of you might have some input, and I'd love to hear your thoughts on some of the available Python libraries that are out there. So summing up things, the Data Factory it's a great tool, but keep in mind that version 2 is still being developed. The documentation is kind of slim in some areas. So I had to do a lot of my own research. I would occasionally find a YouTube video that could guide me in the right direction, but I rarely found examples that fit exactly to what I was trying to do. But I'd get a little piece from one video, I'd get another piece from a second video, and so on. And then there's the data type issue with the variables. I don't really get it. It seems like an oversight, but I'm sure Microsoft has a perfectly fine explanation as to why you can't have a variable of type int. I just haven't been able to find it yet. And I don't want to sound like I don't like the Data Factory, because it couldn't be more the opposite. I absolutely fell in love with the Data Factory. It was slow at first while I was trying to figure everything out, like how to utilize the dynamic content with the expressions. But now I can quickly build complex Python pipelines with very little effort using the Data Factory. And I also don't want to completely diss the mapping data flow component, because I do think that it's a great tool for easily designing scalable ETL or ELT processes. It just wasn't the right fit for what I was trying to do, with the lack of support for loading the SQL database. It was just very frustrating, slow, costly. The hundreds of stagnating open sessions were just too inefficient. While it did take a little bit more time up front doing this with SQL, it was much more efficient and less costly in the long run. Now with Azure serverless functions, more support for Python is something that I really hope Microsoft is working on. They're constantly rolling out new things, so I'm hoping that's coming. It was frustrating because I'd read a lot of the documentation early on when I was planning my design. So for example, I thought that it would be possible to make an insertion into the database from the function. And the reality is you actually can, just not with Python, with Azure lacking that SQL database binding. But .NET platform using C#, no problem. And the other problem with Python is not being able to write or test the Python code within the Azure portal. I spent a lot of time debugging, having to deploy the code every time I made a change in order just to test it. As for the web scraper, as I was just saying, the cloud version of the web scraper is just not worth the money, in my opinion, for this kind of job. The browser extension is really great for quickly creating, custom scrape jobs, and I think that's pretty cool. But if you need a scalable or automated solution, I feel that the cloud version is just not the best option. Just too costly, and it doesn't always perform as expected. I think building a custom scraper using Python, way much better solution. And I'm planning on trying that in the future in my spare time. That's really all I have, unless you have any immediate questions for me right now. Because if not, I'm going to turn things back over to Leo. There's my email, but you can also find me on LinkedIn, and I'm going to post a chat with my email and LinkedIn URL, along with the URL that links to my paper for this project.
Hey, Ryan. So
All right.
we have a couple of questions in the chat from Mark. So one is, have you looked at other web scraping services?
See, I really didn't do a whole lot of research. I did a little bit, but I didn't do a whole lot because that was one of the requirements going into this project, was that I use this third-party web scraper that they were already working with. So it wasn't an option for me to change it, but at this point in time, that is where I'm leaning. In my spare time, I'm hoping to kind of dig in and do some research and see if there's something more feasible, not quite as costly.
Sounds good. And kind of along the same lines, have you used or have you looked into Selenium to implement automation?
Selenium was one of the ones that I found when it came to the scraper, and I did read about that. I started realizing that that was something that I could use as far as this automation goes, and so I'm really interested with Selenium, and like I said earlier, I'm looking forward to hearing any feedback that if anyone has worked with any of these and could possibly provide me. That would be great.
Awesome. Well, yeah, those are all the questions in the chat.
Yeah, Ryan,
Yeah.
this isn't really a question as much as a statement that Microsoft got serious last year about supporting Python when it hired Guido van Rossum.
Aha.
But it as with most things, it's just going to take a while for that implementation to fan out into the Azure Data Factory.
Right. See, I noticed that a lot of the support was really new. When I started, researching this back in September, I noticed that they were really working on it, trying to provide more support for Python. So that's why I was really hoping that, it's heading in the right direction with that. So that's good to hear.
And Chuck, check the chat log. Chuck just posted something about scraping from within Amazon, I think.
Scraping something. Let me see where is everything moved around on me now. I'm trying, here it is. Possibly use blog entry if you weren't forced to use the scraper. You mentioned, API tutorials. Okay. I am definitely going to look into that. That looks pretty cool. I appreciate that. Any other questions or comments?
Slap that bass.
I'm always doing that. All right. I'm gonna stop sharing here.
Yeah, it looks like we're a little early on time. So Leo, feel free to go into more detail, or we can end earlier.
All right. Can I go ahead and share my screen?
Yes.
Do you see my screen?
Yep.
All right, awesome. So hello again. Before I go into the presentation, let me say that a lot of my students complain about me going really fast. So if I ever go too fast, please feel free to send a message in the chats asking for a slow down. But I'll try to be careful with that. And with that, let's go back to the project. So with this project, we're trying to select number of reviews that will represent the overall corpus the best. Now, best is not really clearly defined. So let's talk about the metrics. And the metrics we have is the total number of words in the subset. This subset can have 1 review, 2 review, 3 review in terms of our project, but there's no limit to n sets of reviews. The second criteria we have is number of reviews in the subset. So whether it has 1 review, 2 review, or 3 reviews, since we're trying to minimize it in an optimal situation, it would be less reviews. And then distance between subset and the corpus. This is I will go into more detail how to calculate the distance, but it's basically calculation of how similar the review subset we chose to the corpus, which is the overall all of the reviews. And then finally, content coverage. This is about the subset covering at least minimum amount of certain content from the corpus. Now, in Klein's paper, he breaks down the optimization models into 2 groups. The first one is reading, minimizing. Here in this matrix, we have 4 cells. The first one is number of documents. What we are trying to do here is trying to minimize the number of documents while it's subject to different criteria. So the first one would be trying to minimize the number of documents that's subject to the content level. That will be the minimum threshold. And then number of documents with maximum distance subject. So we would try to minimize the number of documents which meets the distance threshold. At the bottom, we have the number of terms, words used. In this one, we are trying to minimize the words. I'm sorry, in the upper layer, it was actually number of documents, which is number of reviews. So we are trying to minimize the reviews, whereas on the second row, it's number of terms in the subset. Once again, we have 2 constraints subject to the content level and subject to maximum distance. So these are the reading minimization models. And then we have the content maximizing. Here we have two constraints. It's the number of documents and number of words. We are trying to minimize the distance while having a threshold on number of documents. So for example, if we would like to see at most 2 documents, 2 reviews, which one would have the smallest distance from the corpus? And then the second constraint, instead of documents, we have number of words. We will have, for instance, 400 words limit on the subset of reviews we pick. And with that constraint, we will try to minimize the distance. Any question about the models? Okay. Now, to calculate the distance, we somehow need to convert this text data into a numerical value to calculate the distance. So there is a known concept called document term frequency matrix, which lists the documents and the terms, or in other words, the words in them. And the document term frequency matrix can be in different forms. There's binary bag of words or document term frequency matrix. There's non-binary and n-grams. Here is an example. I have 3 small sentences. And if you were to look at the document term frequency matrix for these 3 documents, we would first look at the binary one, which is the top table. Here we see only 1s and 0s for the terms. The terms at the top in the columns are also will be referred as dictionary later on. So these are all of the unique terms in my set of documents. And for each document, whether it has that word or not, I will assign a binary value. And this matrix will be called the binary document term frequency matrix, or binary bag of words for documents. Whereas on the second one, we see numbers other than 1s and 0s. Here, we actually store the actual frequency of the term. So if a term occurs multiple times in that document, we put the frequency to related cell. So here we see some different numbers for document. For instance, the term "the" occurs 2 times, and let's see, there's another 2 for document 3 for car. Now, I did not show the n-grams here, but because it would not actually fit to the presentation. But for this third one, what we would have is different grams. So let's say, first of all, the second one we have is a 1 gram document term frequency matrix. If you wanted to move it to 2 grams, for columns, we would have the combinations of words. So the first column could be the car, and then car was going, so on and so forth. And then based on the frequency, we would create the document term frequency matrix. Now with 2 grams, there's this catch. It could be up to 2 grams or 2 grams. If it is up to 2 grams, then you would include the 1 gram ones. So you would have the car was as separate columns than the 2 gram versions. And if you went to 3 grams, then you would have 3 terms, adjacent terms combined and their relative frequency. So this is how we represent a text document in a numerical form. Any questions on this? All right. Now, here's the code I used. There's a common library called sklearn. I think actually the library is called scikit, and sklearn is a specific module of it. Here you see the count vectorizer. Here in the count vectorizer, I pass 3 different things, the n low and n high. So if I were to do 1 gram, I'm sorry, 2 grams, up to 2 grams, then I would put n low 1 and n high would be 2. So the n low is the bottom and n high is the top threshold. But none of these parameters are, all of them are optional, none of them are mandatory. The default value for n gram is 1 gram. So if you don't put anything for n gram range, you will get 1 gram document term frequency matrix. The second parameter you see there is the stop words. The scikit sklearn has a built-in stop words list. And I use that one to eliminate some stop words. Now, this is actually a important piece of our project. We were really hesitating to use stop words because in the nature of stop words, different libraries have different lists of stop words. There are articles mentioning how different these different stop words lists are. Different libraries, there are over 10 that I actually found during my research had completely different set of words while having some common things such as the, as, and words like that. Now, like I said, we were really hesitating to use stop words because our goal was to make this method in a way that you can repeat with anything. Now, since we are not sure what the content is, a specific stop word list could have an important word in it that we would get rid of. So an example is for one of the products I chose from Amazon, which was a woman dress, and it had a word called A line. Well, A alone can be detected as stop word, but A line actually means a specific thing. So using the stop words, I would actually lose that, which is the reason why we were hesitant. But in the end, we had to use the stop words because in our calculations, the stop words were throwing the numbers off. They were we were having a lot of outliers in the values in the document term frequency matrix. Therefore, we decided to use the stop words list after looking at it and seeing that it has a small list of stop words. And here in the documents, I passed the documents, the CSV file, and then it does a bunch of things such as feature names. Those are going to be the columns. And then I do transfer it to a list and then transfer it to a data frame with the feature names terms being the columns. All right. Now let's look at some results of the data. Like I said, we chose 3 products. Let me tell you why we chose those 3 products. So when we were starting this project, we realized that the product choice would affect the results a lot. That was our assumption because different products could potentially have different vocabularies or different styles in the types of review. For instance, when a book review can be more descriptive with high number of dictionary length, or in other words, vocabulary, a SSD or a women's dress could have less or more in its vocabulary. So we specifically chose 3 different products that we thought could potentially show a different behavior, and we would like to catch that behavior. Now, looking at the first table, we're also seeing that the minimum number of reviews on our products is over 1,000. We chose this number to be between 1,000 and 4,000 to, first of all, eliminate the problem of having computational limits. We would need a threshold for maximum number of reviews. And for the lower threshold, we chose 1,000 because less than that would worry us about the how accurate would the results be. So to have the higher sample size, we chose 1,000 threshold. Now, looking at these, we see that SSD has 1,000 reviews, Dress has almost 4,000, and the book has close to 2,000. Looking at the average word count of different reviews, we see that the Dress reviews tend to be, or on average, have less words, even though there are more reviews, while the SSD has the highest average word count each review, and book has a close number to SSD. The second thing is max word count, so it's the longest review. This result actually did not surprise us. We expected book reviews to be longer, so the largest book review was actually over 1,300 words, while the longest Dress review was 196. That's 10 times almost, or 7 times shorter. And SSD had almost 1,000 word in the longest review. Now in the word count, minimum word count, you will see 1s and 0. You may think how a review can have 0 terms. Now, I looked at this data specifically, and these minimum word counts for specific reviews were due to special characters they use. So I am not 100% sure if Amazon is actually enforcing a limit or like the minimum word count now, but some of these reviews had only a smiley face with a colon and a parentheses. And during the data cleaning process, I eliminated those and they were left with 0 terms. And then looking at the dictionary length, we see the book has over 7,000, so book has the most vocabulary. SSD follows it with 4,700, and Dress right around 4,000. Now, I also would like to mention what I did to get these values. After getting the initial data from Web Scraper, I used Microsoft Power BI to clean my data. The reason why I chose Microsoft Power BI is because it was compatible with the tools that I was familiar with, like SQL. And the second reason was that it was producing DAX code, which could be copied and pasted to repeat the exact same steps I followed if you also follow the same sitemap and get exactly same data. Now, let me share my Power BI screen.
Leo?
Yes.
On your word count column that you just showed us, what are the numbers in parentheses following the average word count?
That's the standard deviation.
Thanks.
Yeah. So let's go to Power BI. Thank you for that question. That was a good one. Well, let's change it. It's not this one. Right here. So right here, I had the initial data, which I can just go to follow the steps on the right side. I have applied steps. If I go to the source version or older version, I see how the data looked like. So for instance, the first one, there were no column names because the initial row was not recognized as the header row. So I had that, and I had the link, the URL to that specific review. I had the author information and the title of the review with dates and content, which is the review itself, with some rating, and also whether or not these reviews were verified, and how many helpful votes they got. Now, we were hoping to look at different analysis of these reviews. So we collected things like verification and helpful votes, but we did not have enough time to actually analyze that. However, I actually have a couple of examples on the selected subsets, whether or not they were verified. I will look at them later. I will show them later. Things I did on this data was pretty simple steps. I made the first row the header. I got rid of some columns that I did not need, such as the URL. I changed the date format to only have, so you see that there's a location on the date too. So I got rid of that to just have February 28, 2018. On the rating, I had a text data, 1 out of 5 stars. So I had to convert this to an integer if you wanted to do some analysis. So I got rid of the text and converted it to integer in one of these steps here, and then got rid of the reference and next. For verification, I had to convert these to true false binary values. For verified purchases, I just set them to true. For helpful votes, it was a little weird. There were 3 cases. It could be null, which would mean no helpful votes. If there's only 1 helpful vote, it would say one person found this helpful without actually using a numerical value in the data that comes back. But anything greater than 1 would actually have the number, like here, 3 people found this helpful. So I also converted this to have just a number where null takes the value 0. Now, about how we would repeat this process is if we follow the same sitemap, which I can provide, it would provide us exact same columns. And looking at my DAX code right here, you could just change the document location and paste everything else. And that would apply all of the steps I followed, which is what I did for other products. I just copied the steps and applied them to other ones. Any question about Power BI piece and data cleaning piece? All right, once I had the data cleaned up, I just transferred this data into a CSV file, which would be used in the code to create the document term frequency matrix. Let's go back there. The second table here has information about the stop word elimination. On the first column, you see the total number of words before the stop word elimination, and on the second one, after the elimination. Now you see that while the book data had more stop words, there was not a significant difference for this value across the corpuses. Also, I think having this kind of result made sense because when you have a larger vocabulary, there's a higher chance of having stop words included in there. So having 284 for book data did not really surprise me. And if you look at the SSD and dress, even before the elimination, they had a similar number of words in their corpuses, and their total number of stop words eliminated were also similar. Now, in the next step, we reduce the data. The main reason for this was because our computational limits. If you go back and look at this data, we will see that dress, for instance, has 3797 reviews. So 1 gram matrix would produce a 3797 by 4000 matrix. That's quite large. And for 2 gram, it would go even beyond that. And the second thing we would need to take into account was the combinations. So if you were to look at sets of 1, sets of 2, sets of 3, that's n choose k problem. So for dress, we would have 3797 without any reduction. If you were to look at all combinations of 3 reviews, that would be the 3797 choose 3. And I think there are a little over 9 billion combinations. And for each of these, we would have to calculate the distance from the corpus. So it was causing some serious computational problems. And secondly, we also realized that there were some outliers that we were almost certain that would not be included in the results. So for instance, if a review has less than 5 words or 10 words, it was really unlikely, that was our assumption, to reduce the dimensions. We said that if it is less than 10, then it's probably not going to help much. Now let's go back to the steps. We first eliminated stop words, then we eliminated words that do not have enough variance, which I will go into that in a second, and then eliminate reviews that have less than 10 words left in them. So at the first stage, the first table right here has the numbers from the previous table, exactly the same numbers. And after the step 1, we see the term count is reduced. That's the elimination of stop words. Now on the third one, you see that the term count goes down drastically from 7,000s to 3070s. What we did here is we looked at the binary document term frequency matrix of all of these reviews. And we chose binary on purpose because our goal was to see if a word appeared in documents all the time or not enough times. So if a term is used only in one document, on every document, there's not enough variance, therefore they would not contribute to differentiating the review from the corpus. So we calculated the standard deviation. Since the values would be only 1 and 0, the high standard deviation we would have was 0.5, which in the case of having half of the reviews having that specific term and the remaining half not having the term. And our threshold was 0.25 standard deviation. We played with this value to look at the term count. Once again, we chose this arbitrary number, which is actually something that a future study should or would like to explore, playing with that number. But our main goal was pulling it to the limits of our computational resources. And then once we eliminated those so-called unworthy terms, unworthy in the sense of not helping us differentiate the reviews, we were left with these term counts. And while looking at those reviews, we said, well, some of these now have less than 10 words in them. And we thought, once again, that they would not really, they did not realistically have a chance of ending up in the optimal solution due to its low term count, which would result in high distance between the review and the corpus. So we said less than 10 words left, eliminate them. That brought our review count down to between high 200s to a mid 400s. So with that, we had the final reduced data that we would use in our process. Any question about this data reduction? All right, I was actually expecting some questions about this piece. Let's keep going. Now, the next thing is vector space model. So we had the reviews represented in a numerical form. But what happens after that? How do we calculate the distance, so-called distance between documents or between a chosen document and the overall corpus? Now, for that, there's a known model called vector space model. So with this, each term in the corpus, in the dictionary, would be a dimension. So in book's case, we would have over 7,000 dimension before the elimination. But after the elimination, we have 39 dimensions. And the documents represented in not dotted lines would have a position in that vector space based on their term counts. And then using a basic Euclidean distance function, we could look at how similar these two sets of documents are. So here, the first one, the DR is one document, CS is corpus, and then we're just taking the difference between each dimension and taking the square of it, summing it up, and taking the square root of it, which is what we would basically do in trigonometry to find the what was that? Hypotenuse, I think. That's what it's called in English. So you would just take the square of two sides and then square root of it. You would get the hypotenuse. So that's what we did for getting the distance between them. Now, a point to make here, the calculation of distance, in that process, we did not use the original terms, which would make the whole reduction process meaningless. Therefore, we use the limited terms. The second thing is we converted our vectors to unit vector because for high value, high review ones, it would actually work in their advantage and eliminate the low review ones, even though they capture the content, but does not have repetitive information. So let's say the term drive occurs a lot in the corpus. If a review has drive once, it's talking about that concept. But another review that just repeats the term drive would end up being in the optimal result, which did not make sense to us. So we calculated the unit vector. Now, other than the Euclidean distance, there are some other models that you can use for finding how similar documents are. One is cosine method. I'm not going to go into details of it, but it's available. And there's another one, which I can't recall right now. Any questions about the vector space model?
Dave, go ahead, Arti.
Yeah, I think David asked a question in the chat. Doesn't this about the metric? The question is, doesn't this metric have a problem with the curse of dimensionality?
Can you explain it further?
Hey, David, can you explain that in more detail?
And well, okay. Oh, yeah. So that's something I actually mentioned in future research piece. So that part is called lemmatization. So drive and drives, run, ran, or like fit and fits essentially mean the same thing. So to deal with this problem, there's lemmatization. We, however, did not apply it to this project, but we said that that would be a good future study, because in our results, we actually solved the problems with it, but due to the limited time scope and the resources, we did not go into that. Does that make sense, Chuck?
David, can you unmute yourself? Clarify your question.
Oh, my bad. It was David, not Chuck. My bad. All right, I'm just going to keep going. And David, you can just put in chat, or in the next stop point, I would gladly answer the question. Now we are getting into results piece. Now in the results, I will show you, let's see.
Sorry, I figured out my microphone.
All right, so what was the question?
Well, cursive dimensionality is where you have, so all these dimensions you're showing are your different keywords, basically. So if you had 1,000 keywords that you retained, the problem is this is high dimensional. So everything becomes equidistant in high dimensional spaces with a Euclidean metric. It's like you take imagine you take a cube and then you round off all the corners because you make it more dimensional, and it becomes more like a sphere.
Oh, that's true. That's true. Although it would make a difference with unit vector Euclidean distance, because if there's a drastic difference between these reviews, let's say majority of terms used in one review or not used in the other one. That was our goal to catch with this, but I see what you're mentioning, and I would like to look into that further.
Okay, and then the other thing is this is unweighted. So you have no weight, all you have is variance of each keyword.
Well,
right? Your metric here doesn't reward a very distinctive keyword versus, variance is your only measure.
well, it has that, because the unit vector I'm normalizing the frequencies. I'm not using the binary here. During the calculation of distance, I'm using the actual non-binary frequency matrix, and then I'm normalizing it. So if a term occurred 10 times and the review itself has 1,000 words in it, it will be 10 over 1,000. So it would be normalized with the unit vector.
Okay, thanks for the answers.
Thank you for the questions. All right, so let's look at some of the results. Before I get into results, I would like to say I will show only 2 models, and towards the end, I can explain why the other models did not work. But the models I will be showing is the reading minimizing first, and then content maximizing. Now, in this one, I was applying the reading minimization, and this is the book review. The solution I found had a distance of 0.7. The solution was from 2 grams, and the document IDs are listed there. Actually don't make much meaning if you don't have my thesis document, but I will show those documents in the slide upcoming. But what we are going to look at here is, this is a histogram of the corpus and the chosen solution. So here you see the normalized values for each term, their frequency, and the orange line represents the overall corpus, while the lighter color represents the chosen subset. So we see a similar behavior here. Now, there are 2 things here. One, you see that the word book itself has this high value that throws things off. Now that relates back to the stop words. We could simply manually add the term book into our stop words, but then it would not be automated. We would have to create a different list of stop words each time. The second thing is we were actually hoping to get rid of words such as book with the data reduction piece, because if it is that frequent overall, we thought it would get removed, but it ended up being right below the threshold, so right above the threshold, so we kept the term book. And on the light line, you see that there are jumps, and it's due to just occurrence of the word once or zero. You see a smoother line for the corpus because each term occurs at least once, right? Or if the terms are eliminated and not left, then it wouldn't be there. But for the chosen subset, you will see jumps from 1 to 0. So 1 is for when it occurred only one times, and then it didn't occur. But the important point is that they share the worthy terms, so-called worthy terms that we found. And the reviews for those three, for that book product, are here. Can you read the screen? I don't know if you guys would like to read it, but there are some points that I will make. Can you read it?
Yeah.
Okay. I was worried that it was too small. But looking at here, actually, a couple things I noticed. One is if you look at the first and the second review, you see quite positive things. Whereas on the third one, it's a negative review. And that tells us this method actually, I mean, this was an expected thing because we did not do any semantic analysis. But we did not really expect to have this much of difference between the selected ones, but it makes sense as it covers both positive and negative sides of the product, perhaps. But once again, this was an exploratory thing, so we just tried to look at how it behaves. And for book review, this is how it behaved. So in addition to the histogram, we also created a word cloud. And on the left-hand side, we have the corpus, and on the right side, we have the subset of reviews. And between these word clouds, at least for me, there's a high similarity. So the terms used most are shared between the corpus and the subset in terms of weighted frequency. The other thing is just like in histogram, you see the term book takes a lot of space, and it is probably as an outlier affecting the other ones. So that is something I would like to look at in the future. Any opinion, any question about these word clouds? All right. So
Leo, a quick question.
Yeah,
what was the runtime to find these three, to match up or extract or identify these three?
Okay, so let me tell you about that. First of all, we calculated this for 1 gram, 2 gram, and 3 gram, as well as sets of 1, sets of 2, and sets of 3. So for each of those situations, we had different values. And I think I have a document, I kept the times for it, but off the top of my head, I can tell you the longest one was 2 hours-ish. And that was a 3 gram and sets of 3. While the 1 or 2 gram and sets of 1 and 2 were almost instant, or like a couple seconds. So it was mainly the sets of 3 that started increasing it a lot. And I would run out of memory, and I started to solve that problem. I just dumped every once in a while the data and write it to the drive. And then after throwing it, that would save up some space in the memory and keep going like that. And I think I did that with every 500,000 combination. After every 500,000, I throw away that data, or in other words, dumped it into the hard drive and then ran it. Most of the time was spent on actual calculation of distance. Other things in the app, not in the app, but in the code, did not really take that long. And I'm not sure if it's the most optimal code, but let me show you the code if we have time. Let me see. Oh, maybe I should keep going, and then if we have time, we can go back, because there's still a good bit of stuff. Now, what I'm going to tell you about these is, first thing we notice is we almost never got a, not almost actually, we never got a subset with 1 review or 2 review. So in other words, no 1 review or 2 review represent the overall corpus, doesn't matter how many words in it, as well as a combination of reviews, which makes sense because different reviews actually capture different points made in the corpus. The second thing we notice is the n-gram. None of the solutions actually provided a 3 gram solution. And that is because, let me show you if it was here. I don't have it here, but I can tell you that between 2 grams and 3 grams, no different terms survived the data reduction. So from 1 gram to 2 gram, we had different terms that survived. But from 2 gram to 3 gram, we did not any new terms surviving the data reduction. Now that perhaps makes sense because there are less combination of 3 words, in English or in any other language. The most common ones will be 1 or 2 word with a different meaning, to have to, but the combinations of 3 words is not as common. So that's why it did not survive in our project. That's my assumption. And I actually checked it with some data, and it was proving that. Any questions? Okay, I have the reviews for these 2. Oh, my bad, let me go here. So you see this one chose n-gram 2. It was not as close in this one. You can see the distance is higher. Overall in the hard drive, the SSD data set, I saw that the minimum distance was a lot higher. So not even the best solution among our reduced data set. When we did the brute force, we couldn't find anything as close as other corpuses. And then the solution we have here is n-gram 2. And let's see. Oh, I forgot to mention the constraints on this. I calculated these values and found the solutions on SQL. Once all of the combinations were created and dumped in the CSV format, I imported that data into a SQL database and ran a bunch of queries with, in this one, for instance, I had the subject to distance. So there was a max level of distance that I put, which was 0.1. And then I tried to minimize the term count. And I have different tables showing the total word count of this. But among the ones that less than the distance threshold, the best solution was this one with the lowest term count. Now, obviously, I could choose another optimal solution, but this is a dual problem where basically it's like supply and demand. So when one increases, oftentimes the other one decreases. So when the term count increases, then the distance gets smaller. Now, on that side, I created actually all the possible solutions and I showed them in my thesis. These are just some examples I picked. But for all of those values, if you would like to see the top 10, for instance, choose your own so-called optimal, because it's actually based on what you want to read. A person can say, I want to read at most 200 words or 400 words. So if you want to look at the top 10, you can refer to my thesis, which I can share a link to. And as time gets close, I'm going to go a little faster. Here, these are the word clouds between the corpus and the chosen subset for the SSD product. We see similar words. Now, it is, once again, not as close as the other one, while we see some common things, like drive, crucial. I believe the MacBook occurs a couple times right here. We don't see as good of a result as the book one, and it confirms with the distance, because the book product, the optimal solution I chose had a distance of 0.73, while this one has over 0.9. Any questions? All right, so then we have the dress product, and for this one, we also got a 3 review subset as the optimal solution. And even in top 50, we had no single or 2 review subsets to get into the subject to distance that we chose, which is an arbitrary number in terms of how many words or how close we want it to be, which could be adjusted with anyone who wants to apply this. We see a similar behavior. I'm not going too much into detail with it. I can tell you the difference between the book and the other two. In the book, we had 2 positive, 1 negative review, whereas in the SSD and the dress, all 3 reviews are positive. And when I looked at the overall rating, I actually saw a high rate of positive reviews in these reviews, in these products. So perhaps that makes sense. Once again, we look at the word cloud, and like one of you mentioned before, the lemmatization becomes an issue. You see the fit here. So there's fit, but there's also fits. So if you would lemmatize it and consider them as same meaning words, then the numbers would change a lot. But like I said, that was for another study. And now I have the results for content maximizing. In this one, my goal was putting a subject to word count and less than a word count. And I was trying to minimize the distance, which would maximize the content. And in all of the solutions here, once again, we didn't see anything from 3 gram options, and we did not see anything from 2 review or 1 review subset. Now, the other strange thing was both for content maximizing and reading minimization, we actually got the same solutions, same set of reviews. So if you look at the reduce reading minimization for book, you see these 3 reviews. These are the same ones that came out from the content maximizing right here. So I did not share the review again. Now this occurred for 2 products, both for book and SSD. The result, I'm sorry, for book and dress, the results were same from the 2 models, whereas for the SSD, we had a better solution in content maximizing, but it did not actually make a huge difference since it was a content maximization and we were trying to reduce the distance. The difference between those 2 solutions in the different models was less than 0.003. So the other one, if the other one was 0.075, this one was 0.072. So the difference was not a lot. So overall, I can say both of these models produce similar results, very similar results. And it is because, like I said, it's a dual problem. So if you look at from cost supply and demand, you'll reach the same result. When supply increases, the demand decreases, or vice versa. And let's skip these, because once again, they're the same word clouds. That's why I'm not showing. In the discussion, let's see. Now, let me go back and tell you why the other models did not work and how they could actually work. Let's look at this one. So on the minimization side, we see number of documents and number of terms. Because we could only do subsets of 3. And just to mention this, if I went to subsets of 4 for, let's say, 4,000 reviews without any reduction, that would be trillions. And for 5, it will be even greater. Our initial goal was to go up to 4 or 5 to find that sweet spot, but we had to stop at 3 because of the computer limits we had. Now, the issue with number of documents was, since we chose only up to 3, 33% of it was 1 review sets, 33% the 2 reviews, so on and so forth. So there was not enough diversity. So the solution you would choose for minimization of the documents, and you choose 1 review subsets, there's no difference between those 33%. It was not differentiating enough to pick one. Every time you run it, you can get a different result. Therefore, the document number of documents reduction was not valid. Now, that being said, I think if you went to 5 or 6, we could have actually see a bigger difference, but we would again have the issue of running the same query but getting different result all the time. And from here, I'm sorry, the content, charts, documents, maximum distance. Same thing here. The number of documents that got eliminated, and this one got picked. But let me go in here. Why the content level did not work. So obviously, I explained number of documents. So the top row did not work. This is the first one, reading minimization, that I showed, which worked. And this one we could not apply because of this reason. So for a number of terms and the content level, the approach we took was we looked at the weighted frequency of the corpus, and we said, let's look at a combination of reviews that have at least let's say 1% of what the corpus has for that term, and the remaining ones, not the 7,000. But in most cases, only 1 or 2 survived for book, but for other products, none of them survived. So perhaps having a content level in that sense was not a good idea. Or if we had 5 reviews, we could perhaps have candidates that meet that requirement. But even the minimum requirement was not met by any subsets of reviews. So therefore, this one got eliminated. So from this 4 different models, the bottom right is what worked. And from the second one is the number of words constraint with the minimized distance that worked. And the number of documents was not successful. Any questions on that? Why we eliminated? Why those did not work? Any suggestion why it did not work? Opinions?
I have a different question about the number of documents that you were processing for SSD and DRESS.
Mm-hmm.
Could you go back to those counts?
After reduction?
No, but yeah, that one. You were there just a moment ago. Okay. Yeah. So you had starting out 7,300 for book and about 47 or 4,000 for SSD and DRESS. But in a later slide, you talked about a tuple that showed up in terms of similar documents that had the same number. And I think for the SSD or the DRESS, the document ID was higher than 4762. And so I was wondering, how do you get a document ID that was greater than the number of documents that you have?
Here I'm only showing 1 grams. Actually, for 2 grams and 3 grams, these would be different because in the 3 grams, there are more terms than what you see here. So for instance, for SSD, I believe there were 72. Therefore, the number of reviews survived changed as well.
Okay. Also, when doing some random choices, a seed is either defaulted or selected, and I'm wondering if you might have gotten a seed reuse between your runs.
Yeah, that could be why. But also, if you think about it, when you're, for instance, looking less than 2 reviews, you're left with 33% of the data. It's not a good threshold. It's not helping you pick the best one because you'll be left with so many options if that's the only criteria for optimization, which is what was described in those 2 models in Klein's paper.
Right. It just occurred to me that if you've got the same documents that were paired up, that in 2 different review sets, that perhaps there was a random number seed that was being used that caused the same documents to be matched up, and you're just getting the best of those sets.
Yeah. Oh, I see what you're saying between the 2 models, reading minimization and the content maximization.
Yeah.
Okay.
From later on, when you're describing the documents, the reviews that you showed us for either SSD or DRESS, and up at the top you've got which reviews they were, and you noted when you showed us those slides that I don't think it's this one, but it's another one that had like 6,000, that those 3 were the same as different reviews. Like this one was
it's
the same
as the content maximization one. We get this exact same set. Is that what you're saying?
Yeah.
Yeah, exactly. That's what we noticed. Our the way we interpreted it is because the both models essentially looked at the same dual problem. You know, there was no third thing to look at. When the number of words decreased, generally, the distance increased. So when we chose similar thresholds, we got similar results in those two. Not sure if that makes sense. So essentially, we're saying that both of these models will produce similar results, if not the same, based on the approach we took. So if we change the dimension reduction process, we may see something different. If we did lemmatization, we could see something different. If we tried different sets of reviews, we could see something different. Now let's look at the other points as I'm slowly running out of time. I already mentioned most of these. I said lemmatization would be a good future research thing. Stop words. I don't know if there's a good way of creating or automating the stop word creation for different sets. So if I could create a list of stop words from scratch based on the product itself, that would be an interesting thing. So that way we would get rid of, for instance, book or drive, because obviously book doesn't make a lot of sense to take into consideration for differentiating reviews, because it's about a book. The product itself is a book. So I'm curious if anybody has an idea about generation of stop words based on the document and doing it in an automatic, repeatable sense. But I was not able to find anything. And with Ngram, I already mentioned this before. I think, once again, we might get a different result with a different data set, which is why I provided all my code to be able to repeat this with different products. We can see a different result, but based on this research, 3 gram was pointless, and it just increased the computation time, because there was no difference between the dictionary after dimension reduction between 2 gram and 3 gram. If 2 gram increased the surviving words from, let's say, 70 to 75, 3 gram also had 75 exact same ones. Problem with number of reviews, I mentioned that we couldn't go any further than 3. Therefore, it is something we would push for. Content constraint is also related to the previous bullet point, because if you increase the number of reviews, then possibly more subsets will survive in content constraint, which in which we were trying to look at a percentage of corpus to appear in the subset, say 1%. I really tried low numbers for these, like 0.5%, 1%, but for 2 reviews, none of them, for 2 products, none of the subsets survived. So that was another issue. Choosing the right threshold. We chose some arbitrary numbers, and I'm totally aware of it. And in most cases, those decisions were based on limiting it into a dimension that that was reasonable. So when we were playing with the numbers, looking at the numbers, we looked at the distribution of it, and there were some clear points where cutting, like they were more accumulated in one region, so we cut it off at those sweet spots that we thought were sweet spots, but there's not enough data to support our claim or the numbers we picked. So that's something to be further investigated. Let's see, questions overall. All right. Like I said, I have a bunch of other slides, but due to the time limit, I will not share it right now. I can share my presentation or my thesis, which has all the possible things I had to really squeeze in the important parts for this presentation, but I can share that. But thank you for listening.
Awesome. Thank you so much, Leo and Ryan, for sharing that.
Thank you. Thank you for having me.
Yeah, definitely. I guess, so we can move on to lightning talks at this time. I didn't see anybody post lightning talk ideas, but just as a reminder, lightning talks are can be about any data science topic in any format between 5 and 10 minutes or less than that. So does anyone want to present a topic at this time?
I've got one. I'm still here.
Cool. Yeah, we could. You want to go first, Mark?
Sure. Let's see if I can do this. Oh. Share. Okay. In case you haven't seen it, Microsoft just announced an emergency patch. Everyone who's working on Windows, even as far back as Windows 7, should apply this patch. It's a vulnerability in the print server for Microsoft Windows. So, security alert. The next is there's some KD Nugget articles that are worth reading. Here is a Weight Watcher library that could tell you whether or not your machine learning model is overtrained. I will post the links to these, everything that I'm going to show you in the Meetup page for this meeting. Okay, moving on. An automated data wrangling article from Catalyst Cooperative. It's a longish article, but when it comes to data wrangling, I'm a big proponent of trying to move as close as we can to automation whenever possible. And so there's plenty of stuff that you can come away from this article with some ideas and things to try. So anyway, HoloClean being the first one that they show you. A GitHub repository called Soda, and if you've already got your data into rows and columns, into a table format, Soda can be used to check the goodness of the data or check for missing data. You create a YAML file and kind of specify what kind of constraints you want it to check against, and then it dynamically generates the SQL to go out and look at the table that you've captured on a variety of different let's see, right, so these different Microsoft SQL Server, Postgres, Snowflake, Apache Hive, Google BigQuery, etc. So it will generate the SQL and let you know whether or not you're missing values, and it's kind of like data profiler for pandas, except that it is for any kind of row and column data that you've already gotten. Leo mentioned semantic search, and this brings us back to another KD Nuggets article, measuring meeting from Jacquard to BERT. And once again, this is in the realm of natural language processing. I will post the article, and I think, yeah, this is the article from which I got the Arthy's opening statements, which is if you've got a $1.6 trillion company based on based on similarity, yeah, it's probably worth your time to at least look at it. And then finally, and medium.com has an article on seven different types of classification using Python. Definitely a half an hour read, even if you don't get out your Python or Jupyter notebook and do any of these, and plenty of code examples to show you what's going on. And they're using a large data set. I think it's from Belgium, Belgium banking data dump. So there's plenty of data that you can get to through the article, and then all the code examples to take you through different classifications. And I don't know where I am in terms of 5 minutes, but that's what I wanted to show you. Thank you.
Cool, thanks, Mark. Anyone else want to give a lightning talk? Anyone? Okay, well, if not, I guess we can end a little early. Just a quick reminder that these sessions are recorded and will be posted to the PyData YouTube channel. So you can search PyData Triangle and you can look through any old recordings that we have. And then lastly, our next meetup will be Wednesday, September 1st at 6 p.m.
Thanks, Leo. Thanks, Ryan and Mark, for contributing. Appreciate it.
Thanks so much for your presentations.
Have a good
Thank
night.
you, Gene. Hopefully we can meet one day and have some beer together. Oh man, I'm jealous now.
Have a good night, guys.
You too.
Bye.
Bye-bye.
Night, everyone.